Hello everyone. Today we are going to do the experiment magnetic lines of force and locating null points or neutral points. So first of all, what is a magnetic line of force? How do we define a magnetic line of force? A magnetic line of force is defined as the path along which a unit north pole moves. Actually, in magnetism, we cannot isolate north pole and south pole separately, but just to define, we say so. So let us see how we are going to do this particular experiment. So the apparatus that is required is this compass needle, a magnet, and a drawing board and a white paper. So first, you keep this compass needle on the white paper. I keep the drawing board and the white paper like this. What is a compass? What is the purpose of compass needle? Compass needle always shows north and south of the earth. So it is coming to rest in this particular direction. That means the north of the room is in this direction. So what I should do? I should turn the drawing board. I should keep it parallel to the north and south. Once I set it, I should not disturb it till I complete the experiment. So I've set it. This side it is north. So you have to indicate this in this particular direction. This is north and south. So this is east and west. So this I have done. I have located on the paper. Now when you are doing this adjustment, setting, okay, indicating east, west, north, south on the paper, you have to keep all the magnets and magnetic material away from the work table. I have done so. Now, I'm taking this small magnet. You take this magnet, this is enough, just 1 inch, 2 inches otherwise. 2 inches magnet is sufficient. If you take bigger magnet, what happens is the lines of force will go out of the paper. You can't locate the null points, etc. So I have taken a small magnet. Now the next thing for us to do is to locate the poles of this magnet. Okay, for some magnets, they write north and south. Nothing is written on this. So how to locate? Now I keep randomly. So here you have a dot. That also not universal. For some north, the white dot indicates north. For some magnets, the white dot indicates south. So, okay, I'm just keeping randomly the white dot in this particular direction towards north. So, if I get the null point, if the north of the bar magnet is facing the north, geographical north, that is north of the earth, you will get the null point on the equatorial line. So, yeah, I'm getting the null point. We'll come to to define what is a null point, but I'm getting the null point here. So that means what is this pole? North pole. We have to do this experiment in 2 different cases. First case, or any one case, you don't have first or second. One case is the north of the bar magnet pointing the north of the earth, and the second one, the south of the bar magnet pointing the north of the earth. Listen. Okay. So here, so let us say we are doing this first. This is the north of the earth. Now I kept the south of the earth pointing the north of the earth. Then I should get the null point on the axial line. So I'm just reversing. I got when I just put it randomly, I'm getting it on the equatorial line. First of all, what is axial line? What is equatorial line? The straight line passing through both the poles of the magnet is called as the axial line. This is the axial line. And the perpendicular bisector which is passing through the middle of the magnet is called as equatorial line. So I'm just reversing the pole. That means this is definitely south pole and this is north pole. You have done it. Just check once before you proceed further. Yes, I'm getting the null point on the axial line. That means the setting which I have done, that the south pole pointing the north is right, because I'm getting the null point on the axial line. Okay, I put the magnet. Now what you are supposed to do is you draw the outline of the magnet. You draw the outline of the magnet neatly. You must do it. So, the general mistake done by the students is when they want to draw this, they take the magnet out. They take the magnet out and talking to their friends, etc., while keeping, they reverse the magnet. And they say, we are not getting the null point, we are not getting the null point. So, once you locate it, just to see the dot is towards you. The dot for this particular magnet is North Pole. So, you have to keep the other one towards the north of the earth. Okay, I set it, everything is ready. Now, we have to start the experiment. Where from to start? You can start from any point, the end of the magnet, and okay, I'm just keeping it here. You should start from the North Pole actually. North Pole I have started. When you start at the North Pole, it comes to rest at one point. So, you indicate the tail. Okay. Now, you lift it and again you keep the magnet at that point which you have indicated. Another dot like that. You go on. It will direct you. You don't have to do anything. The magnetic needle itself directs you, guides you how to put the points. Okay. So, only thing is you have to put it at one point. It comes to rest at one point. Where it is coming to rest, that point you have to note it down. Now, I have got a set of points. With your free hand, you should not use a scale for this particular purpose. You draw a line, a curve. It is actually a curve joining all these points that gives you magnetic line of force. Over. Now, I have to start on the other side. On the other side, I have started. Again, it is coming to rest. Actually, the tail should be placed. The tail should be placed at the starting point. Okay, the head you note it down. Now, yes, like that, you draw another line through all the points. So, one set of lines is over on either side. Another thing also I should tell you. Students' experience, my experience with students, they say one side the curve is bigger, the other side the curve is shorter, smaller, like that. See, it depends on you how you will adjust. Okay, you just change the point where from you are starting, then you will get the lines beautifully symmetrically on other side. Okay, now you start at a different point at the North Pole. So like that, you go on marking till the end. You'll get another line of force. This way. You should not draw the line first and then indicate the points. Okay. You just put the points, go on till the other end, and then two lines over. Now, how do you get this particular line? I'm starting at this point, any point. Okay. Then you go on marking the points. It will take you like that. You'll get it. So, similarly, this side. I can't draw all the points, but this is how you are going to draw. Now, one more line also you can do. One more line. Definitely it will come inside only. So, like that, you draw with your free hand. Now, Never you should return your answer script without indicating the arrows. What are arrows? Arrows indicate the direction of magnetic line of force. What is the direction of magnetic line of force? See, if you just give, in this experiment, there is nothing except the arrows. Arrows are so important. The direction of line of force is for a bar magnet, it is from north to south. Definitely it is from north to south, I can say. Why? This compass needle is an approximation to a north pole. Now, when you keep the north pole, light poles repel each other. So, this is stronger. When you compare the strengths, this magnet has a stronger pole strength when compared to this one. So, therefore, it exerts force of repulsion on this. So, it won't be towards. So, this bar magnet exerts a force of repulsion. That's why this direction will be away from the north pole. Away from the north pole. And we said this is an approximation to north pole. So, this is the compass needle. You may get a doubt how it looks like. See, this is a small magnet pivoted at the center of this circle. Okay, and it rotates in a horizontal plane. North, south, east, west are marked. Depending on that, you can set it. In whichever direction, what is the trait of a magnet? What is a magnet? Tell me. What is how magnetism is invented? What is a magnet? Magnet always shows north and south. So in whichever direction you turn it, twist it, whatever you do, the north pole always comes to rest in this particular direction for this two. Okay. So that is the trait of magnet. Okay. It always shows north and south of the earth. Okay. So here from the north pole, the direction of line of force is always away. And this is an approximation to north pole you can treat, I said. Therefore, this south pole attracts this. North pole repels it. South pole attracts it. Therefore, south pole it will be towards. Now, what is a null point or a neutral point? You can call it either null point or a neutral point. You take a bigger scale and draw a line through the poles of the magnet, and you also have to measure the length of the magnet. It will be, say, roughly, I know it is 4 centimeters. So a midpoint is at 2 centimeters. Now you keep this magnet like this. Okay, at one point it is showing in this particular direction, straight. Okay, it is parallel to north-south here. But at one point, slowly, see, it is turning in the east-west direction. Where it is turning in the east-west direction, that is called as neutral point. Okay, so just locate it on the axial line, on the axis of a magnet. Similarly, on the other side, here. So, anyone you can call it as N1, anyone you can call it as N2. No problem, because you are going to take the average of the distances. Now, how to make another general mistake done by the students? They measure the distance from the end of the magnet. No, that's not correct. You have to measure from the midpoint. So, from the midpoint on one side is D1, and from the midpoint the other side is D2. There may be 0.2, 0.3, slight difference between D1 and D2. You are going to take the average. So here I have written here D is equal to D1 plus D2. D2 by 2, because that is the average distance which you will get it in centimeters. This many centimeters you will get. You have to convert it into meters. So here this is the formula for magnetic moment. What is magnetic moment? How do you define magnetic moment? Magnetic moment is defined as the product of length of the magnet and pole strength. Small m is the pole strength and capital M is the magnetic moment. You cannot write whatever letter you like to write in physics. Small letters indicate something, capital letters indicate something else. So here small m is the pole strength and capital M is the magnetic moment. And what is 2L? 2L is the length of the magnet. Okay? Don't take this. If this is 4 centimeters, if this is a scale, I'm putting it on scale, I got the total length of the magnet to be 4 centimeters. Don't multiply that by 2 and take 8 centimeters. The length of the magnet itself, scale. The length of, see here is the scale. As I told you, this is the 4 centimeters. This is 4 centimeters. 4 centimeters is 2L. You should not multiply that by 2 again. 8 centimeters you should not write. Magnet's length is represented always by 2L but not L. Okay, length of the magnet itself is 2L. So this is the formula. And what is happening at the null point also I should tell you. At the null point, why are you calling it as neutral point? We have actually this mapping of magnetic lines of force we are drawing in the combined magnetic field. What is that combined magnetic field? We have two fields. Yes. One is the field due to the given bar magnet. And what is the other field? Earth is also a magnet. Yes. So we have magnetic field associated with Earth also. So these are the lines of force which we are drawing in two cases in the combined magnetic field of Earth and the magnet together. So at this point, N1 and N2, the two fields are becoming equal in magnitude and opposite in direction. That's why the needle is not showing any deflection. Okay. So we are equating H is equal to BH and this value 0.38 into 10 power minus 4. So by that, if you substitute, this is the formula. M is equal to HD cube into 10 power 7 by 2. For this particular one, on the axial line. That means when the south of the bar magnet points the geographical north, this is the formula. And the unit of magnetic moment is, here I have written ampere meter square. Ampere meter square. Okay. Why ampere meter square? See, M is equal to 2L into M we have written. L is the length. Length unit is meter. And what is the unit of pole strength? Ampere meter. Ampere meter. So you have ampere, meter into meter, meter square, ampere meter square. Okay. And magnetic moment is a vector quantity. So that is about how we are going to draw the magnetic lines of force when the south of the bar magnet is pointing the geographical north. Now let us see the second case. Second sheet. Just a minute. It's there. So now we are going to do another part of this experiment. When the north of the bar magnet is pointing the geographical north. So again, same thing. First, it's okay. Same thing, we have to look at the north, south, east, west of the earth. When we are doing it, you have to keep the magnets and magnetic material away from the work table. So I kept it. It takes just a few seconds. to come to rest. See, in this particular direction, it is coming to rest. If I keep like this, what's happening? In which direction is it coming to rest? Tell me, in which direction it is coming to rest? Cross. In this particular direction. So I have to move. Such that this is. You should not disturb it. Students, they're not understanding this point. They set it. Again, while doing the experiment, they turn it. They keep it in a comfortable position for themselves. No. You should not do like that. Okay? It should definitely be in north-south of the earth. Okay? So, you turn it. Till what time you should put it in this particular condition? Till your experiment is completed. Okay? So, don't disturb it. Till the until and unless you completed. So, what is the first thing to do? Location of north, south, east, west. Don't indicate it at the bottom of the paper. At the top, you should indicate. Okay, so I have indicated that north, south, then this is east, this is west. Some students, they keep the magnet in the east-west direction and do the experiment. Note down these points, okay? We don't have that. Only two conditions. The south of the bar magnet pointing the geographical north, point to the north of the bar magnet pointing the geographical north. Okay? So, now earlier we have used the same magnet. Now you know the white dot indicates north. So, I'll keep this in this particular direction. Okay? Now, I should get the null point where? East and west. Okay, on the perpendicular bisector I should get. See, I got it. That means your setup is right. You can proceed. Next thing for me to do. Okay, draw the outline of the magnet. And how do you measure the length of the magnet? By scale. Okay, just take 4 centimeters. What is equal to 4 centimeters? 2L. 2L is equal to 4 centimeters. You can write at one corner and keep it ready. And while keeping it, be careful. The dot should be in this particular direction only. Okay, now I can start the experiment.
Yes.
I'm starting here. Okay, now I should start at the North Pole. So, indicate all the dots, joined. Similarly, start at the other end. Suppose one side the curve is coming bigger, the other side the curve is coming shorter. You just start at a different point. Okay? And one more important precautions which is asked in theory also. See, all these lines are, any two lines are crossing each other?
No.
Meeting each other? No, they should never meet. They ask you also in the theory, why two magnetic lines of force ever intersect each other? Enduku khandinchukovu. What is your answer? Suppose they meet like this. Suppose they meet at some other point like this. Here, this is the meeting point, no?
Yes.
So, if they meet like that, it means that at that point, the magnetic field has two different directions. One is in this direction, the other one is in the other direction. No, it's not possible. It's not possible because at a given point, a magnetic field has only one particular direction. Okay? You can't say to the examiner, I got like that only. It is impossible. It is absurd. It is impossible. So don't draw like that. They should be very clear. Now, okay, I have started. Then start at a different point. How do I get, now we are drawing this. Now, how do I get second line? See, first line, I have taken one point. Second line, I should start at a different point. Different point. So, like that. I'm drawing because I know how they look, but you should not draw like this. Here are the dots already there, I indicated. Okay.
Yes.
Some students, they draw the line and put the points. It's wrong. You should not do like that. Now, this is not pole. You should indicate the poles on the sheet also. Now, what is the direction now? Here. Okay. North to south, I told you, no?
Yes.
So, downwards they will be. And here, you just choose this. It will go like this. Here, it will be like this. And how do I draw another line? You start at some point. It will take you towards the south pole. Like this you will get. And how do I draw these lines? These lines. Here also some students, they draw inwards. No, you won't get inwards. You will get like that. Okay. So, like that, you will get. Here you will get like this. And null point will be, let us look at the null point. In between these two only, you'll get null point. See, one arrow is downwards, one arrow is upwards. In between only. Students bring the null point here and they draw the line like that. చూడగానే తెలిసిపోతుంది తప్పు అని. Okay, you should that should be in between. See, here. Huh? In between. Similarly, the other side, in between. So, on one side, this you call it as N1, the other side you call it as N2, and from till the middle you measure. This is D1, the other side it is D2. D is equal to D1 plus D2 by 2, and
D2, D1.
Whatever it is, no problem, I said, no. Okay, for us to have symmetry, call the N1 side, you call it as D1,
and
N2 side, let us call it as D2. D is equal to same formula, D1 plus D2 by 2, and magnetic moment HDQ by into 10 power minus 7. On the axial line, the formula is HD cube into 10 power 7 by 2. Here 2 won't be there, except that everything else is same. Okay. So this is how you have to draw the magnetic lines of force. I'll just show how you will get the magnetic lines of force from this only. Just see after drawing how they look like. So this is how we are going to get the lines of force when the south of the bar magnet is pointing the north of the geographical. Now, what are the precautions that you should take in this experiment? Firstly, when you are setting up your drawing board, all magnets and magnetic material should be away. Point number 1. And when after setting the drawing board in magnetic meridian, okay, in north and south direction of the earth, you should not disturb the board, and poles should be located correctly. That is how we are going to draw the magnetic lines of force using a compass needle and a given bar magnet. Thank you.